Section 9.5, adding and subtracting rational expressions. Now, remember when we're adding and subtracting fractions, let's say we had the example 1/3 plus 4/7. If we want to add these together, we need a common denominator. So then I would have to think, what's common between 3 and 7? I know that what's common between that, or my least common denominator, is going to be 21. So how do I get 21 at 7 times 3? So then I look at my first fraction. I say, well, what times 3 is going to give me 21? I know that's going to be 7. So I would multiply this fraction by 7 over 7 because that's like multiplying by 1. So it doesn't change my equation at all. And for the second one, 7 times 3 would give me 21. So I'd multiply this fraction by 3 over 3 because that's like multiplying by 1 and it doesn't change my equation at all. Now I'm going to use that to help me simplify it. So this would be 7 times 1 is 7 over 21 plus 12 over 21. And then when you're combining fractions, you take the numerators and add them together. So 12 plus 7 is 19 over your least common denominator, which is 21. That doesn't simplify at all, so that's my solution. So the first thing that we need to do is figure out how to find your least common denominator, and we're going to do that by practicing by finding the least common multiple first. So to find the least common multiple, multiply multiple of two or more polynomials, factor each expression. The least common multiple contains each factor the greatest number of times it appears in the factor. And then you're going to multiply those together. So let's start with numbers because those are usually easier to do first. If we want to find the least common multiple of 4 and of 6, well, the first thing I would want to do is find to simplify 4 all the way down into prime factors. So 4 can be written as 2 times 2, and then 6 can be written as 2 times 3. So again, the least common multiple contains each factor the greatest number of times it appears in each of them. So in this case, if I want to find the least common multiple between 4 and 6, I know that the greatest number of times that 2 appears in either of the two equations would be twice because we have 2 of them in 4. So the least common multiple is going to be 2 times 2, and then if you look at 6, we have a 3 that appears once in the equation, so times 3. So 2 times 2 times 3 is equal to 12. So my least common multiple between 4 and 6 would be 12. Now let's do that with polynomial equations. So I have 4x squared minus 36 and 6x squared plus 36x plus 54. So the first thing I want to do is find the prime factors of each expression. That means I want to factor it. So if I factor this first one, I can take out my greatest common factor, which is 4. When I factor that out, I get x squared minus 6. And then x squared minus 6, two terms. I know that, or not 6, sorry, that should be 9. So two terms. So x squared minus 9. I know that x squared and 9 is a difference of squares. So this gives me 4 times x minus 3 times x plus 3. And then 4 can still break down because 4 is the same thing as 2 times 2. So this would be 2 times x minus 3 times x plus 3. So that's broken down all the way. Then I'm going to do the next one. So I want to factor this next part. So I have a greatest common factor, which is 6. So if I factor that out, I get x squared plus 6x plus 9. And then I can factor, I want factors of 9 that add up to 6. So I have 6 times, in this case, x plus 3 times x plus 3, because 3 times 3 is 9 and 3 plus 3 is 6. We've already talked about factoring. And then 6 can break down into 2 times 3. So this is really 2 times 3 times x plus 3 times x plus 3. So this is factored as far as I can possibly factor my equation, and so is this one. So I want to write each prime factor the greatest number of times it appears in either expression. Now I don't combine the two, I just find the greatest number of times it appears in either. So let's start with our numbers first. 2. I have in the first equation 1, 2 2's here, and I have 1, 2 in this equation. So the greatest number of times it appears in either would be 2. So I have 2 times 2. Now I'm going to go to the next one. So I have x minus 3 appears once here. It doesn't appear in the other one, so the greatest number of times it appears in either would be once. And then the next one I have x plus 3. I have 1 here, but I have 1, 2 in this equation, so that means I'm going to write it twice. X plus 3 and x plus 3. So that means that this right here is going to be my least common multiple, except for I missed one thing. I forgot the 3 right there. So this is also being multiplied by 3. So 3 times this. So we know that 3 times 2 is 6, and 6 times 2 is 12. So really, this is equal to 12 times x minus 3 times x plus 3, and I have 2 of those, so squared, and that's going to give me my least common multiple, and that's going to help me find my denominator that I want. So let's look at the next example, number 2. Find the least common multiple of 18a cubed b c squared and 24b squared c squared. So let's go ahead and do some stuff off to the side here. So 18a cubed b c squared, and then we want to factor that. So 18 is the same thing as 2 times 3 times 3, because 2 times 9. So 2 times 3 times 3, and then a to the third bc squared. You could write a times a times a, and then c times c, but it's not necessary. And then the next one we have is 24 b squared c squared. So then 24 breaks down into 2 times 2 times 2 times 3 times 3. And those are the prime factors. And if it helps, you could make a factor tree to get that, because 24 we know is the same thing as 8 times 3. And 8 breaks down into 4 times the 2. And I know 2 breaks down as well into, or the 4 breaks down as well into 2 times 2. So that's where I get 2 times 2 times, and I wrote too many 3s there. 2 times 2 times 2 times 3 would be my prime factorization. And then I have b squared c squared. So if it helps you to make that factor tree to get the prime factorization, that's fine. So like if I would have done the same thing for 18, 18 breaks down into 2 times 9, and this breaks down into 3 times 3, so that's where I get 2 times 3 times 3. Now I'm looking for my least common multiple, so I'm looking for the greatest number of times any number appears in either. So my least common multiple, let's start with the 2's. I have 1 here, but I have 3 here. So the greatest number of times it appears in either would be 3. So 2 times 2 times 2, or you can just write 2 to the third. And then if we look at our 3's next, I have 2 here, and I have 1 here. So the greatest number of times it appears in either would be twice, so 3 squared. And then I'm going to go to my next term, which would be a. I go in order of the alphabet. So then the greatest number of times a appears is going to be 3, because we only have a third in the upper equation, not the bottom one. So that one we just did here. Then I would go to my b's. I have 1 here and 2 here. So the greatest number of time it appears in either would be squared. And then I have 2c to the second power, because I have c squared here and here. So 2 to the third times 3 squared times a to the third times b squared times c squared would be my least common multiple. And of course I can combine those numbers together. So 2 to the third is 8, and 3 squared is going to give me 9. So 8 times 9 is 72. So that's also the same thing as 72 a to the third b squared c squared. So you can write it either of the two ways. Now, if we look at the next one, find the least common multiple of 5 and a minus 1. So the least common multiple, 5 doesn't factor. So because it's already prime, and a minus 1 doesn't either, so my least common multiple for this one is just going to be 5 times a minus 1, and that would be my solution. Okay, so let's go ahead and look at some more examples. To add or subtract rational expressions, they must have the same denominator. That's really important. If the denominators are different, find the lowest common denominator. Note you may need a factor. After you find the least common denominator, multiply the fraction's numerator and denominator by the missing factors to get a common denominator. So that's like what we did up here with the first equation that we did right here. So our least common denominator is 21, and then I multiplied the fractions by the missing numbers to get the least common denominator. So the 3 I needed to the 1/3 I needed to multiply by 7 over 7, 4 over 7 I multiplied by 3 over 3. And then we want to add or subtract the numerators, combine like terms in the numerator, and simplify. And we're going to leave the denominator in factored form for now. So for this first equation, 5 over 6 plus 4 over 9. So first things first, I want to find the least common denominator. So my least common denominator, I'm going to do just off to the side down here. I have 6 and I have 9. So you should be able to do this without writing it out. The least common denominator between 6 and 9 is going to be 18, but just in case if you need to write it out, that's okay. So here I know I have 6, the prime factorization of 6. If I break this down, we have 2 times 3, nothing else breaks down, so just 2 times 3. And then 9 would be, in this case, 3 times 3. And then if you look for the greatest number of times the number appears in either, the least common denominator is going to be, we have 1, 2, and then 3 appears twice here, so 3 squared. That means my least common denominator is going to be 2 times 9, which is 18. So if I go back up to my question, 5 over 6 plus 4 over 9, I have to look for what's missing. How do I get 18? So 6 times what number gives me 18? Notice that I'm missing that extra 3, so that means I need to multiply this by 3 over 3. That's the missing factor. And I multiply the 9 by 2 over 2. That would be the missing factor there. Now I can go ahead and start to simplify this. So 5 times the 3 gives me 15 over, in this case, 18, plus 4 times 2 would give me 8 over 9 times 2, which is 18. Now that I have a common denominator, I combine my numerator. So 15 plus 8 is 23 over 18, and this does not simplify it, so that would be my solution. So that's my simplified answer. So let's look at number 2. So for question number 2, I want to first find my least common denominator. I have AB and I have A. So AB doesn't really break down anymore, it's just A times B, and neither does A. So the greatest number of times A appears in either of the two would be once. The greatest number of times B appears in either two is once. So my least common denominator is AB. So go back up to your equation. So for the first fraction, 6 over AB, I look for any missing factors to make my least common denominator. I already have it, so I don't need to multiply that fraction by anything. But if I look at the second equation, I have 8 over A, which means I'm missing the B, so I need to multiply this by B over B to get my common denominator. So when I rewrite this, I have 6 over AB, which was already my common denominator, plus 8B over AB. Now that I have my common denominator, I can add my numerator all over my common denominator. So this is going to be equal to 6 plus 8b. Those are not like terms, so I can't add them together, all over ab. And then that would be my simplified answer. I can also factor the numerator. The numerator you can factor out a 2, which would be 2 times 3 plus 4b over ab. And nothing simplifies there, so I'm going to leave this as my solution for right now. Technically, this would be my answer though, because nothing simplifies, but we can factor that, and since nothing factors out, that would be it. So let's go to the next problem. Number 3. So for number 3, first I wanted to look at my denominators. Notice your denominators are the same already. It's x and y. So I already know my least common denominator is going to be xy. I don't have anything missing, so I don't need to multiply either of my fractions by anything. That means all I need to do is combine my numerator over my common denominator. So I have 2x plus 1 plus 4x minus 2. So when I combine my numerator, 2x and 4x go together, which gives me 6x. And then 1 minus 2 is minus 1 over xy. That does not simplify any further, so this would be my solution. And I know the other day we were talking about restrictions, but from now on, we're going to assume that any variable in our denominator cannot be equal to 0. So let's do question number 4. So for question number 4, again, we're going to look at this, and I want to find the least common denominator. So the first fraction here is already factored. So we have x minus 4 and x plus 4, and then x squared minus 16. I would need to factor that first, so this is going to be the difference of squares, x minus 4 times x plus 4. Well, notice that those are the same when I factor, so my least common denominator is x minus 4 times x plus 4. So I don't need to multiply either equation by anything because I already have my common denominator when I factored that. So everything gets added in my numerator, so 5x plus 2 over my common denominator. And this is going to give me my solution. Now let's look at number 5. This one's going to be a little bit harder. So for number 5, I would do the same thing. First, I would want to factor that equation, the x squared plus 5x plus 4. So I want factors of 4 that add up to 5. So 4 and 1. So this is going to be x plus 4 times x plus 1. And then for the next one, I can factor this fraction into 3 times x plus 1. So I need to find my least common denominator first, which is going to be x plus 4 appears once in the first fraction, and then x plus 1 appears in both once, and then also I have times 3. So this is my least common denominator. That means if I look at the first fraction, I'm going to rewrite this so it looks a little nicer. Now that if I have this, I have to look to see what I'm missing. So if I look at the first fraction, I have x plus 4 and x plus 1, but notice I don't have that 3, so that means I need to multiply this by the 3 over the 3 to get my common denominator. For the other one, I am missing, in this case, I have 3 and x, so I have these two. That means I'm missing the x plus 4, so that means I need to multiply this by x plus 4 over x plus 4. When I do that, I'm going to multiply my numerator and denominator by the number that makes my least common denominator. So 3 times 1 would give me 3 over 3 times x plus 4 times x plus 1. And then this would be 5x times x, which gives me 5x squared. And then 5x times 4 would be plus 20x over 3 times x plus 1 times x plus 4. Now you notice that you have the same denominator, so we combine our numerator all over our common denominator. So my common denominator is 3 times x plus 1 times x plus 4. And I'm going to be combining my numerator. So in my numerator, I have the 3 here plus the 5x plus the 20x. None of those are like terms, so I'm going to write it in order. 5x squared plus 20x plus 3. And then, of course, before I am done, I would want to make sure that I can't factor this any further. So you could try to do the slide and divide method. 5 times 3 would give you 15, but you don't have any factors of 15 that add up to 20. So that means that this right here is going to be my solution. So make sure you have that with you for class, and we will do problems 6 and 7 together. If you missed something on the video, make sure you just go back and look at it. And maybe even I suggest watching the video again if you didn't understand how to find the least common denominator.